Hello, this is checkpoint 1.26 from section 1.4, and they want us to look at this function y is equal to 1 over x squared, but restrict its domain. So originally its domain would be, if we just look at this, it'd be all real numbers. X is a real number, except x cannot equal to 0. So this is the domain of the function without it being restricted. But now they want to rewrite our domain, and so now we define our new f of x function, f of x, when you define an f of x function, you not only write the function, but sometimes you are also allowed to restrict its domain if you want to. So in this case, they changed the domain to just be all numbers that are less than 0. So x, real number, such that x is less than 0. So that's what it means when they say minus infinity to 0, which means your graph should only look like this, and it'll stop at 0 and not including 0. And this whole thing gets wiped out, essentially. So then that part's gone, and this is all you have. So clearly, if your domain is this, we can see that the range is just going to be a positive part. So range is equal to all the y values such that y is bigger than 0. Cannot equal to 0 because this is an asymptote. Okay, so that's the domain and the range. Well, we can also find and graph what this is going to look like. And so that's the f function. Now let's try to find out what f of x is going to look like. We'll draw it here. Or f inverse, sorry. So what we're going to do is we will take this function, write y is equal to x squared, or 1 over x squared. And remember, the two-step process is to solve for x and then switch the x and y. So we'll do some cross multiplying or something like that. We will get x squared is equal to 1 over y. And then we need to solve for x. So x will equal to the plus and minus the square root of 1 over y, which, by the way, is just plus or minus 1 over the square root of y. Now, we're going to switch the x and y. So y, well, first let's stop here for a moment and pause. And we're going to note that, well, y has to be bigger than 0. We kind of knew that already, so that's good. That's going to be part of our information. And then the other thing is that we want the x to be less than 0. So there's a plus and a minus here because we want x to be less than 0. We're going to want this to be a negative. So x is equal to negative 1 over the square root of y. So that's going to be the inverse function. And now, so that's step 1. Step 2 is we'll switch the x and the y. And when we switch the x and the y, we'll get y is equal to negative 1 over the square root of x. Oops, can't see that anymore. Let's take just do a shift, and then we will see that our function, we'll call it f inverse, is going to be negative 1 over x squared. Oops, negative 1 over the square root of x. All right, so we know that the original function with its restricted domain looks like that, and we know that its inverse graph is going to be reflected about the y-axis, or the x equals y line, and so we know that the graph of the inverse will will be a reflection. And then we also know that if we have the domain and range for the original function, the domain and range for the inverse will just be switched. So we can write the domain of our f inverse function will be equal to the set of all x values, real number, such that x is going to be bigger than 0. Oops, bigger than 0. And you know that matches with the range over here. And then the range of this function, of the inverse function, will be looks like our pen's running out. There we go. Will be equal to the set of all y values such that y, so now this is y is less than 0, because looking at the graph, it's below the x-axis, and you can also look at the original function, and that was the domain. Now it's the range. Okay. All right. I hope that helps. Good luck.